Good morning, ladies and gentlemen. We want to talk about a cybermaster performing penetration lab. Now, this is a scenario given to us. So, as you can see, these scenarios explain what the, this expert has to be done. You are a certified security professional contracted by a manufacturer of consumer plastic to perform a penetration testing on their industrial control system network. The SCADA software that communicates with the programming logic controller PLC is written in MicroPython and running on a STM32F40 405RG microcontroller board. The company suspected that custom Python script could interfere with the operating of the PLC, controlling and injecting modeling machines. Your task is to modify an existing Python script on the microcontroller that control communication with the PLC. The goal is to simulate reconnaissance and the enumerate of the network to identify PLC and collect information about the operational status. You will need to modify the script to include loops and conditional conditioner that scan the network for connecting PLC and check their status, implementing Boolean and string operator to evaluate the response for each PLC, determine whether it is active or inactive. That is number two question. Number three, once identifying, use arithmetic operator to calculate the reports, the numbers of the active and inactive PLC. Finally, adjust the script to simulate an attack by replacing the original logic controlling the PLC with a new function that will interfere with the operation. Ensure your modifying script handling edges cases such as timeout or non-responsive PLC by including appropriate error handling and retrying in your looping construct. So this is the instruction given to us. So this is the question himself. So we are using a Python script now. This is a programming on Python script to determine how to eh, make an options. So the first question before me say what variable could be modified to simulate the operational status to detect the PLC. Now the only thing we use modify is the status. So this is the status. So the status. So it is the status that is being modified. So all these ones have a stable variable. This one is set to be 0, but the status is the one that you can modify because it doesn't have any fixed value. Number two, what is the role of the status variable in determining PSC operational state? So the state of the operational variable is to do what? Is to store the status. So keep on storing the status. That is the major role. That is the major role it performs. Number three, which variable could be modified to control the scanner looping that enumerate multiple PLC? Controlling. So what control the loop is this? You come to this place. So we have the looping right on the down here. So you can see. Let me go down here. So you can see this what control the looping. If the device in the device for y in the range of 0 to 9, step So the step is one controlling it. If it increased by one, I mean equal to, I mean plus equal to one. If step is equal to 9, so the temperature, so you can see this is where the looping is. So what controls, or which variable that will modify the control? So the variable that is modifying the control is steps. If the temperature is 260, what is the status B? Now from the inset, our target is 275. So if the temperature is 260, definitely it's very low, very low, too low. That is the option. So identifying the variable that could be altered to simulate the overheating condition in the PFC. So what could you alter in this process? You can only alter the target. That is all. You can alter the period, the target. So you can change the target. So when you change the target, so everything will come to play because pressure is fixed. So write write a conditional statement representing which value would result in the status OK. The first thing is the temperature. Temperature equal to target. Temperature is equal to what? Target. Are you getting it now? Operation. So this is it. From this status, temperature. So this is my target. If temperature is greater than, that is another condition. Are you getting it now? So this is another condition. If temperature is, okay, this one is less than target. If temperature S is okay, that is when temperature is equal to target, then it's okay. So we find it here. Now write two conditions that would determine the while loop during the PLC. First, you come to power. So this is power. You can see this is the while loop. Power is not is equal to, if it is equal to, then it is what? It is false. That is condition number one. Condition number two, power again. If it is not equal to, then it is what? It is true. It is true. So that answer the question from this code. Why initial variable value would be modified to stop the check function from evaluating the PLC status. The question is when the step is 10, because the step is in between 0 to 9. So if it is 10, you only stop. It's not within the range. That is that. So how many adversary spoof are fake in this thing in temperature? So the only fake one, pressure is ring, the changing of temperature is ring. So replacing the import module. So if you anything replacing the import module, so that one is fake. So that is the status. So thank you for how far you have been with us in this recording video. This is just brief lab explanation on the code written in Python programming language, and this is the question being subjected to that code. Wow, I get it. 16, 16.